Hello folks, so in this video we're going to talk about how we can solve equations that involve the trig functions. And so whenever we hear the word solving an equation, remember, or the phrase solving an equation, all it is just finding the value of x or theta or whatever variable it is to make it true. Sorry, I'm kind of getting blinded here. In this case it's theta, right? And so we want to be just aware of what's going on. That's all it is, really. Again, find the value of x or theta in this case that makes it true. It's just, well, depending on where you are, actually doing that is not so easy, right? So this is an easy equation. If I had something like this, x plus 3 is equal to 4, that's relatively straightforward. If I had something, say, x squared plus 2x minus 1 equals 3, that's a little bit harder, and so on. So again, in the grand scheme of things, you've done this before, just not in this context. So let's take a look at this first one here. We've done a couple examples already in class, but let's take a look at this one. So sine of theta is equal to 1/2, and the thetas that we're actually looking for, normally they would be restricted, but if I wanted to find all the possible thetas or all the possible angles, what would they be? And how could I notate that? So that's what we're going to practice today, or at least in this first example. Okay, so if sine of theta is equal to 1/2, the way I would kind of reason this out is to actually, if I didn't remember my unit circle, at least draw what this would look like. And so we know, well, if I have my unit circle here, then all this would mean is I need the sine value, or if on our unit circle, we're talking about the y value, when does that equal 1/2? Okay, so this would be somewhere over here, pretend. The y value right here, y would equal 1/2. And again, y is representative of sine of this angle. That would be the angle theta there. Okay. Now, whenever we see something related to trig where the value is 1/2, we should immediately know at this point, again, this just takes a lot of practice, what the rest of this triangle is going to look like. So I'm going to blow this up a little bit. So I'm going to have right here where the sine value, or the y value, is 1/2. That's our angle. And on the unit circle, our hypotenuse is 1. If we use Pythagorean theorem, or remember that this is actually part of a 30, 60, 90 triangle. And if on the 30, 60, 90 triangle, we have one side being 1/2, the hypotenuse being 1, then we actually know that the long side, the long leg, specifically, is √3/2. And so we can actually already figure out what this angle is. This angle, well, because it's a 30, 60, 90 triangle, is going to be 30 degrees. Or, more specifically, because we like to use radians now, that's going to be pi/6. Here's the thing. That's not the only angle, right? Because if we're looking at all angles theta, so theta could be literally any angle. If I went around 2 pi more radians, one full revolution, I'll get back to that basically the same angle, and the sine of that angle would also be would also be 1/2, 1/2. And so how could I say this? Well, instead of saying, let's see, pi/6 plus, plus another 2 pi would be 13 pi/6, and then plus another 2 pi would be, that'd be 25 pi/6. Well, there's no possible way we could write these all out, right? And so the way we would say this is, I'll do pi/6 plus 2 pi n. And so n is an integer. It's kind of implied whenever you're seeing something like this, that n is a whole number, an integer. And so if I start off at pi/6 and I just add a full revolution, that will be a solution. Add another revolution, that will be a solution. Add another one, that will also be a solution. Excuse me. Now you might be noticing that this is actually not the only angle or family of angles where sine of the angle is 1/2. And you're right, because I'll show this part in green over here. I could also have 1/2, but in the second quadrant here, like so. And then in that case, this would be our angle theta. Okay, if that's the case, we should probably make this a little bit thinner. Sorry about that. If that's the case, then what would that angle be? Well, okay, let's try to keep track here. So the angle theta, I'm going to draw this a little bit bigger. Well, sorry. I'm going to draw my reference triangle or my reference angle here, right? So we know that reference angle. Well, we don't know what that angle is, but we know that this angle over here is theta. Okay, but since the y value is 1/2 right there, and the hypotenuse is still in the unit circle, so the hypotenuse is still 1, we're going to have to throw in a hypotenuse of 1 there, and therefore the other leg is also going to be root 3 over 2. This is another 30, 60, 90 triangle. That's all it is. And so, well, remember this angle right here, that's going to have to be pi over 6. And so remember, theta starts off from the positive x-axis to wherever it ended up. And that would mean that theta itself is 5 pi over 6. 5 pi over 6 there. And we had the same argument, or the same situation that we had previously, where I could take 5 pi over 6, or I could go around another full revolution, and another full revolution, and so on and so forth. And so just like before, we're going to have to add in to a shortcut way to say that we can just keep doing this, is to say another plus 2 pi n. And so these are our solutions. We kind of have two solutions, or two families of solutions. Pi over 6 in every revolution thereafter, or 5 pi over 6 in every full revolution thereafter. All right, so we're going to pause there for this one, and then we'll take a look at how to use a calculator to get the second one.